once again, this is Vex Robotics Team 8655V with the Cube assignment with another robot prototype. We're farther along with our scissors lift idea, and we wanted to show you how it's been going. We've been having some success in building the last few practices. So, similar to our last video, we have the main scissors lift, but what is different, we've added 4 things. The first thing is we have temporarily mounted the motor with sprocket down here so we can test how the chain moves. Second is that we added guardrails for cubes to come over the top so they don't topple over once they come over. Third is we added these to, I'll explain more in a little bit, they help get the cube from down here over this sprocket because it's kind of a tough point. And the fourth thing is that we've made attachments to go on the chain that can actually lift both the cube, and we have a separate component for lifting the Skyrise pieces. The first chain component that we have lifts the Skyrise pieces. The main contraption is a passive cube intake that takes a Skyrise piece, drops down on top of, uses friction to hold it in place, where we can then lift it up and place it on another Skyrise section. When it does, the friction will allow us to take it back up. We have 2 places where the chain attaches to this component, which allows us to move it better and apply the proper force to get it on, which has been a little bit difficult. And the second component that we had shown in the last video, but it's very simple. It's just a chain segment connected to a sideways bracket with some curved pieces of metal that just hooks on like so. The sideways piece is to keep the cube from going side to side. So now I can show you how these things operate once attached to the chain. The first chain component that I'm going to show you is the hook for bringing up blocks. I already showed how it works. So simply, we lower it, lowest we can go. We drive toward a block, have it hook under the front piece of the cube, and we simply raise it up. It turns out that this motor, without being geared down, has enough power to lift it not only up to here, but also has enough power to lift it over the top, which we were having trouble with before. And there demonstrated how these passive beams work. They simply brought up the back end from getting caught on the sprocket. And these guide rails help it to stay straight as we bring it over the back and drop it onto a Skyrise section or a post, whichever one we're doing. To deal with the weight of the cubes on the gears, we had some problems with the entire scissors lift collapsing. So we actually solved that by adding a simple contraption onto this part right here. As we're raising the scissors lift, these 2 metal pieces attached to this hook, which as it goes up, pushes against this beam, and once it reaches the highest height, locks around this bar and locks it in place, so no matter how much force you put on top, it can't come down. So that's how we fixed the problem with the weight of the blocks in the scissors lift instead of the strain being on the motor. And here we have our second, more complicated chain component, which raises the Skyrise sections. So, as I said before, the rubber on these tank tread pieces has enough friction to hold the Skyrise section up while we raise this up, drive forward, and lower it onto the Skyrise section. Then when we pull back up, the friction between these two Skyrise sections allows us to unhook our robot and drive out of the way. Now we can also pick up Skyrise sections using this piece. So pretend this is exactly 12 inches off the ground. So pretend that this is the stand that we'll get it from. It's loosely placed on. We would simply drive forward towards it, pull down enough force on top. Let me loosen this. And then we simply raise it out of its holder, like so. So we have the two parts that it's connected to the chain. First, the top part is used to hold this entire contraption in place so we can raise it when we're raising it up. And the bottom piece here is more important because that's what allows us to get our downward force, because it's kind of hard to try to push this in here. You don't get a lot of force, but when you're pulling something in, it gives you more force. It's kind of like trying to push a rope. You can't really push a rope in a straight line. So this entire square then transfers the weight and balances it out so that we can pull down on it from all sides, giving us enough force to shove this thing in here.
Awesome. Awesome to the max.